Hey there, physics. So our next unit here is going to be about two-dimensional motion, what's called projectile motion. This is things not moving just in a straight line, but moving in more of a arcy kind of line, right? But before we really get into that, we need some mathematical tools to help us out along our way. So to that end, our first target here is going to be about vectors. Our target is going to be able to find the resultant of two vectors, and we're going to understand what that means in a couple of minutes here. All right, the first thing we'll really talk about is the difference between what a vector is and what some other numbers are. There are some, in physics, in science in general, we don't just work with numbers. The things that we work with are not just numbers. They're measurements, right? They're things. They represent actual physical quantities. And some of these quantities have a direction to them, and some of them don't, right? If you think about something along the lines of maybe your mass. Maybe your mass is, you say, I don't know, my mass is 60 kilograms. Would it make any sense to say my mass is 60 kilograms to the left? Wouldn't make any sense, right? Mass is something that does not have a direction. Temperature. It's, I don't know, 70 degrees Fahrenheit outside. Is it 70 degrees Fahrenheit to the right? I mean, that doesn't make any sense, right? So temperature is something that doesn't have a direction to it. But there are many quantities that do, okay? These ones that don't have a direction are called scalars. We call these things scalars. Things that do have a direction, think about displacement, okay? Say I end up 2 meters from where I started. Would it make sense to say I'm 2 meters to the right of where I started? Absolutely. This is something that has a direction to it. Or velocity. Say I'm moving 50 meters per second. Would it make sense to say 50 meters per second to the north? Absolutely. So these things that have a direction to them are called vectors. Okay? So scalars are things that are directionless. Vectors are things that have both a quantity and a direction. There are a few different ways that we can represent vectors, okay? Oftentimes, when we're talking about variables, if we have a vector that's a part of an equation, we can represent it as a vector in the equation. If you see a variable in an equation that's in bold type indicates that that thing is a vector. Okay, italics usually indicate that that thing is a scalar. So if you're looking at an equation and you see some things in bold type and some things in italics, you can tell the bold ones are vector quantities and the italic ones are scalar quantities. When we are handwriting things, oftentimes we'll do math by hand, of course, right? And it's hard to make something in boldface when you're writing by hand. So generally, when we are writing by hand, we'll indicate a vector. Most people put like a little arrow over it, something like this, right? So this is the vector V. So maybe mine usually looks like a little fish hook. Some people make it more like an arrow. Some people just put it like a bar, right? So I see this and this tells me, hey, that thing's a vector. Oftentimes we'll represent vectors graphically. And when we represent vectors graphically, they are arrows, okay? The length of the arrow represents the quantity of the vector, and the direction that the arrow points represents the direction of the vector. So on a graph or on a map or something like that, we can represent vectors with arrows. So there's a few different ways to represent vectors there. Vectors have a couple of useful mathematical properties that we should keep in mind. One property of vectors, a vector has a quantity and a direction, but it has no place. Okay, so if we have a vector on a graph or on a map or something, we can pick up that vector and we can put it somewhere else, as long as we don't change the length of the vector, the quantity, or the direction of the vector, which way it's pointing. So it has a quantity and a direction, but it has no place. So we can move it around a graph, all willy-nilly, however we want. We can get crazy up in here moving our vectors, long as we don't change their direction or their length. The other useful mathematical property of vectors is that we can add them in any order we want. And we're going to talk about how to add vectors in just a second here, but I want us all to remember and understand you can add things in any order you want, and that includes vectors. So we can add our vectors in any order we want. Okay, so we're about to talk about how to add vectors. A couple of things to keep in mind. There's a couple of vocabulary words here. When we talk about the sum of two vectors, you know, when you're in math class and you talk about adding things together, you might call it the sum. When it's vectors we're talking about, there's two different ways that people might talk about the sum of two vectors. One of them, they might call it the resultant. So if I add two vectors together, what do I get? I get the resultant. Some people might also call it the vector sum, which is kind of, makes sense, right? It's the sum of two vectors is the vector sum. The other thing that we should keep in mind here is that in order to add two vectors, they need to represent the same thing, right? The same physical quantity. So I can add two displacements together, I can add two velocities together, but I can't add a displacement and a velocity. They have to represent the same thing. Okay, convenient method for being able to add two vectors is what's called the tip-to-tail method. This helps you add two vectors together graphically. What you do on the tip-to-tail method is you take your first vector and you place it someplace convenient. Okay, someplace convenient is usually with the very beginning of the vector at the origin. So if you place the very beginning of the vector at the origin, that's a nice convenient place usually, right? Does it have to be there? No, you could work everything out with it in any place you want, but it's a nice convenient place to put it. Because remember, vectors don't have a place. You can put them wherever you want. So place your first vector so that it starts right there at the origin, okay? And you take your second vector and you put the very beginning of that vector at the end of the first one, okay? So you've got one vector and then the next one coming off of that. And then the resultant, the vector sum, is a vector that goes from the beginning of the first vector to the end of the second vector. And you can line up as many vectors as you want this way. So from the beginning of the first vector to the end of the last vector, okay? So, an arrow that goes from the beginning to the end, just straight there, that's the vector sum. We might be asked to subtract two vectors. If I'm asked to subtract two vectors, it's really exactly the same as adding two vectors. Just got to keep in mind that when you subtract, you add the opposite. Okay, and the opposite of a vector is a vector that's the same length in the opposite direction. Okay, so it's the same length, just in the opposite direction. So you can subtract two vectors using exactly the same method. So you can make your first vector, then take your second vector and flip the direction and line it up with the end of the first vector. And that's subtracting two vectors. Okay, we're also going to need to be able to add two vectors together algebraically. It's a little bit more involved. That's going to be the subject of our next lesson. Okay, so we're not going to talk about how to do it algebraically in this lesson. We'll do it next time. So this time we talked about how to do it graphically. We're also going to need to be able to multiply or divide vectors by scalars. Okay, we're not going to multiply vectors by vectors. It's a little bit more complex. There's actually several different ways to multiply vectors by vectors. Take calculus, you do the dot product or the cross product, or the different ways of multiplying two vectors. But we're going to need to be able to multiply a vector by a scalar. It's very simple to multiply a vector by a scalar. The product of a vector and a scalar is a vector. It's got the same direction as the original vector, and its magnitude is the scalar times longer than the vector, right? So kind of in simpler terms, x times a vector makes a vector that's x times longer. Make sense? So if I have a vector that is 2, meters that way, and I want to multiply it by 2, then it will be 4 meters that way, right? So you just multiply the numbers and keep the same direction pretty much, right? So multiplying vectors. Division works the same way. to divide two vectors, just divide the amounts, right? And the vector retains the same direction. So whether you're multiplying or dividing, the product or the quotient is a vector in the same direction as the original vector. And again, we're not going to multiply or divide a vector by a vector. You want to learn how to do that, take, vector calculus. Okay, now let's say I have these two vectors. I hope you can see right up next to me right here that I'm going to add when I'm editing. These two vectors are called vector A and vector B. You can see they're both in boldface type, indicating that they're vectors. So let's say I want to add these two vectors together, and I'm going to do that graphically. Well, what I'm going to do is I'm going to take them, I'm going to start with vector A, and hopefully, the image there is changing so that you can see what I'm doing. I'm going to put vector A on a coordinate plane, and I am going to put the beginning of vector A right there at the origin, so that's going to make it a little bit easier for me to work things out. And then I am going to take vector B, and I'm going to put vector B right at the end of vector A, so that vector B is starting where vector A ended. Okay, so you can see how I'm trying to point at it, and it's not actually there as I'm filming this, but there you can see how the beginning of vector B lines up with the end of vector A. Okay, so now the resultant, the vector sum, is going to be a vector that goes from the beginning of A, and since I put the beginning of A at the origin, this resultant is coming from the origin, and it's going to go up to the end of B. So you can see the vector A plus B goes from the beginning of A to the end of B. Okay. And you notice we mentioned a few minutes ago that we can add in any order. Notice if I started with, instead of doing vector A plus vector B, if instead I did vector B plus vector A, I add them the other way, I'd end up getting the same vector, the same resultant as the vector sum, right? So if I start with vector B, starting vector B at the origin, and then I line up vector A at the end of vector B, then vector B plus A ends up coming out graphically, geometrically exactly the same thing as vector A plus B. So isn't that pretty neat? You can add your vectors in any order you want. All right, so that should get us a step closer to being able to find the resultant or the vector sum of two vectors. Like I mentioned, next time we'll do it algebraically. This time we did it graphically. Next time we'll do it algebraically. So finding the resultant of two vectors. Until then, take it easy.